Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And this is a little bit of a topic change from what I intended yesterday. The topic yesterday just required, quite frankly, just too much work to get it done. And so I came up with a different topic, which is equally interesting, if not more. And so that'll be today, sort of a makeup for yesterday. And then the other topic, I hope to be able to get those calculations done so I can share that video with you tomorrow and we'll be all caught up. But I was down, as many of you know, in Perry, Florida last week to experience a Category 4 hurricane. And I got to be honest with you, what I observed was not nearly as bad as what Fran did to Raleigh in 1996, and that was barely a Cat 1 when it got to Raleigh, okay? It wasn't even a fair comparison, okay? So obviously the question is, what happened? Was the hurricane not nearly as strong as was reported, or was there something else going on? Well, there was something else going on. It was every bit as strong as reported, and I'll prove that to you in just a second. So let's go on ahead and take a look at a number of different interesting things here. Now, this is just your basic map showing you where I was. I was in Perry, which is 16 miles from the Gulf Coast, and Adams Beach. I actually drove down there about 7 o'clock that evening, about 3.5 hours before landfall, and the ocean looked like a lake, okay? It was not angry. There were no big waves. I was stunned that this monster hurricane is 3.5 hours offshore, and the ocean, or the Gulf of Mexico, didn't look any angrier than it did at that particular point in time. So everything was very, very concentrated around the center. So again, 16.2 miles from where I was to Adams Beach, right on the Gulf Coast. All right, so here is a split view from the Tallahassee, Florida National Weather Service Doppler radar, and you've got reflectivity on the left, and you've got velocities on the right. Now remember, the Doppler radar can only measure the velocity that is either going directly toward the radar or directly away from it. If the wind is blowing perpendicular to the direction that the radar beam is going, it shows up as 0, okay? So you have to take that into account. Now in this particular case, it turns out that the wind was actually coming from a direction very similar to where the radar beam was going out. So we pretty much got the actual winds, but you have to be careful with that whenever you look at Doppler radar velocity. So here's Adams Beach here and also here. And you see this little circle here. This is an app called Radar Scope where I can actually do a little bit of a pixel query as to the values that the radar is detecting at each individual pixel on that image. So here, and this was about 3,500 feet above the ground, okay? Because remember, the radar beam is going up as it goes out, just slightly, and the Earth is curving away from the radar beam, okay? Because the Earth is round. Sorry, flat earthers, you're wrong, okay? All right, so this was measuring a wind speed of 154.3 miles per hour. That actually is 14.3 miles an hour higher than the maximum sustained wind that the Hurricane Center mentioned in their advisory, okay? Now, the winds are always going to be a little bit less at the surface because of friction, so it's not surprising that you would have a higher wind speed up there. But goes to show you that this was a monster storm. I mean, you don't get 154.3 mile an hour winds if it's a weak system, okay? Now, if we move on ahead here and take a look at the observation a little bit later, at this point, the eye was over Adams Beach, as you can see here, but the eye wall was right over me, right over Perry. And again, at about 3,500 feet above me, the wind was being measured at 132 miles per hour sustained, okay? Now, remember that number because here are the actual observations from the Perry, Florida airport, okay? Now, this is in code, but the one I want you to focus on here is right here. Now, 3:15 means this observation occurred at 3:15 Z, which this time of year is 11:15 Eastern Daylight Time, okay? The wind was out of the east-southeast at 48 knots, which translates to 55 miles per hour, and it was gusting to 86 knots, which translates to 99 miles per hour. So the highest sustained wind that they reported at Perry was 55 miles an hour, and the highest gust was 99. But 3,500 feet above the ground, the wind was at 132 miles per hour. So how can that be? Okay. All right, let's dig a little deeper here. Now, this is the Saffir-Simpson scale description of what a Category 4 hurricane usually looks like at the ground. Okay. It's 130 to 156 miles per hour, so the data that we saw on the radar fits right into that range. Catastrophic damage will occur. Well-built framed houses can sustain severe damage with loss of most of the roof structure and or some exterior walls. Most trees will be snapped or uprooted and power poles down. Fallen trees and power poles will isolate residential areas. Power outages will last weeks to possibly months. Most of the area will be uninhabitable for weeks or months at a time. You know how long it took me to get out of Perry on, Friday morning? About a half an hour. I ran into 3 trees that were crossing the road, and in all cases, I was able to, as other cars were able to drive on the side of the road and get around it, okay? I saw one telephone pole with a transformer on it that was tilted at a 45-degree angle, but it didn't actually come all the way down to the ground. I did see a number of trees that were literally stripped of all the foliage, okay? That was a very, very common sight. And there were trees down, but it certainly wasn't a majority. And I think back to Fran when it hit Raleigh in 1996. Now, admittedly, the wet ground played a major role there. And most of the trees that you saw down in the triangle area were uprooted. You could see the root ball. But, there were trees down everywhere. In fact, finding a tree that was still standing was the exception rather than the rule. And that simply was not the case in Perry, Florida. And this was a Cat 4, okay, and not a Cat 1. Okay, so the closest upper air observation, closest place they send up the radiosondes or weather balloons, was in Jacksonville, Florida. I think they used to have one in Tallahassee. For some reason that they're not doing that anymore. But I want to call your attention to a couple of different things here. So this is the pressure, okay, and this is in millibars, and it goes from 1,000 to 850. The temperature in Celsius near the ground was 27.4 Celsius, which is about 80, about 82. The temperature actually increases 0.6 of a degree Celsius, which is about a degree Fahrenheit, and then it starts to go back down, okay? Now here's the thing that's really interesting. At the surface, the wind was out of the southeast, 130 degrees at 7 knots. And then just slightly above the surface, it goes to 15. And a little bit higher up, it goes to 24. Then all of a sudden, bang, it goes to 58 knots. And then 62, and then 63, okay? So there's a 34-knot jump here between 974 millibars and 925 millibars, and in terms of actual distance, it's about 450 meters, okay? So, and the question is, why is there that much of a difference in the surface wind as opposed to the wind aloft? Well, part of it is this. Okay, the fact that you have an inversion where the temperature actually increases slightly with height, and stable air where the temperature increases with height makes it very difficult for high velocity wind up here to mix down to the surface, okay? Stability does not promote mixing at all. In fact, it inhibits it greatly. So if the environment near the surface is stable, then a lot of those really, really powerful winds up here will not make it down to the surface, okay? Now, this is a sea surface temperature analysis, and if you look at this, if you look at the color table here, the warmest stuff is dark red, and then it gradually gets lighter red, and then it goes down into the yellows and even greens. We were right up in here. You see all that yellow right there? So the water temperatures were definitively cooler right along the Gulf Coast, and you had to go offshore a fair distance before you started getting into these darker oranges and reds. And so, again, if this air is pulled in inland across where I was, then that's going to hold surface temperatures down. You figure right on top of the water, at the water temperature, if it's 85 or 86, which it was, then that means the air right above that water is 85 or 86. But if you're blowing 80-degree water, the air over top of that blowing inland, then that's going to make the atmosphere more stable, and it's going to inhibit mixing and prevent those really strong winds aloft from mixing down to the surface. And then finally, I talked to Kerry Emanuel, my hero up at MIT, who is a retired now, he's a professor emeritus of atmospheric science at MIT. He's actually living up in Maine now. And I corresponded with him today, and he told me this amazing story about the Great New England Hurricane of 1938. They had gusts over 200 miles per hour at the top of Blue Hill, I believe that's in Massachusetts, which is 635 feet above sea level. In some of the surrounding countryside, the winds barely broke 40, okay? So again, that was another example of stability in the lowest part of the atmosphere, not allowing those powerful winds aloft to mix down. And you think about what happened in western North Carolina, where you have strong winds as you go up a few thousand feet, and those mountains are poking right up into that, okay? So it's easy to see how they got some of those really, really strong winds, because they're there at that elevation, and it's like the mountains are saying, hey, let's poke up into that and see what we get. Well, we know what we're going to get. We're going to get really, really strong winds. But in the valleys, where the atmosphere could be much more stable, then they probably didn't have winds anywhere near that strong. Their main problem at that point was the excessive rainfall and no place for that rain to go, okay? So there were different impacts of this storm depending on where you were. But anyway, I just found that fascinating, because I fully expected to, after this eye passed us, for Perry, Florida to be an unadulterated disaster area, and it was anything but. Okay, it really wasn't all that bad. Now, what I would like to do, and I'm going to do this tomorrow, is call the emergency management office down in that county of Florida, I believe it's Taylor County, and ask them if there's any other part of the county that had damage that was worse than what I actually observed firsthand. And I'll relay that information to you as soon as I have that phone conversation. But this is another example of how all hurricanes and all hurricane effects are not created equal. And I thought you might find that interesting as to why things were not nearly as bad where I was as you would think they would with the eye going right overhead. All right, folks, that is bonus weather video number 1 for this week. Hope you found that intriguing. The next one will be coming up tomorrow, God willing, if I can get a few calculations made. And we're going to be talking about something called the diurnal pressure tendency, okay? And that'll be coming up tomorrow. So you all take care, folks, and we'll talk to you tomorrow. See you later.